number 2. Okay. Okay. So now where we are at the transformations. Understanding your inputs to tell output. Somebody should take care. That someone is nothing but a service provider. Some service provider. Similarly, when you write a Java program, what you write? I want to print a output. What I given say hello world. You will give every instruction, main, run it, then you will get the output. But at the end of the day, it should be converted to bytecode, understandable by that, and again print, showing on the monitor. So there are multiple steps of activities being involved in a single instruction. Every single instruction have multiple set of activities. So what service bus will be doing it? It is, as he told earlier, connecting different things, different systems, different platforms as well, different environments as well, and different clouds as well. So there's no end of connecting anything until unless there's a barriers in between, like firewalls and all, proxies and all. That and all have additional stuff. So my point here is Mule is just a service provider, which we call as ESB, Enterprise Service Bus. So why we need a service bus? We just told we need to connect to different systems, but that doesn't enough. Just connecting, I have 2 LAN cables connecting to the 2 systems is not enough. I need some extra software so that I can use these 2 systems to talk each other, communicate each other, right? So how should I understand a input? Somebody saying, when I say hi, you will say hello, or you will also say hi. So you are responding to me. Means we are understanding a common language. We need a common language. And who is initiating the wishing? Like me. I am a source. You are a destination. So we have source and destination. Means which will in our technology terms we say endpoints. From one end to other end. If I say hi, you don't like to say hi again. It's only one way. When you reply back, it's a 2-way. Right? If in radio, jockey will say that, hello everybody, good morning. You will not say good morning to him, right? You can't say, because we are listening to a broadcasted thing. So that is one way. In a phone, you call it is 2-way. So I'm talking about all the lively things which we do generally. And when we think of all these things in a programmatical way, we need a software. We need a software which will allow us to do all these things. I'm sending a file via Bluetooth to you. When we are doing it, what we need to have? I need to have Bluetooth to be activated. My Bluetooth to be activated. There should be pairing to be done. Then only I can send files within a range. Those are restrictions. Correct. So all these things, when we see, it will be easy to do. But when we have to do, then we need to learn this kind of tools. So coming to this, why we need anypoint platform. I'll come back to all the things which I have discussed so far, correlating with the Mule. Thanks, Hari. Yeah, this is my email ID. Can I take this? Yeah, close it. Yeah. So this is our agenda. So we are introducing the anypoint platform, connecting assets to audience. I think basic architecture, IT models, anypoint platform, and there is stack. And thanks to my team who added me a couple of slides. They prepared their. So this is what we are going to learn about specific things. So what you see, I think somebody is talking about Oracle, OSB and all, right? So we have different systems. Name it, we have it like somebody wants to use Twitter and he wants to talk to some employee. Like employee is trying to use a Twitter. There is some connectivity between. All are separate things. So you have an event. You want to publish that event in Facebook, Twitter, LinkedIn, or anywhere. But you all different systems you're talking about. But you are the only one source. You have one item to be published, saying that this is a mule event, please welcome. Okay, you want to publish it. How do I do that? One person will initiate all the things. How you will log into your accounts and you will do all these things, right? No, I don't want to do all these things. I want to write a code. If I say XYZ in this code, it should send to Twitter, it should send to Gmail, it should send to Facebook, everything in one shot. I have just created all the OAuth authentications because I had given my login ID, password, credentials, connected all my systems here. I'll type something, it should visible in all things. That is possible through Mule. You're understanding now why we are into Mule. We want to reduce the donkey's work. That is where Mule comes into picture. So the history of the Mule, how it is evolved. Mule, a person like a programmer like you, asked him to do a coding, and he felt like first day he was very interestingly working on the coding. Second day he has the same work to do again. Second day copy pasted. Fifth day also the same. No, he don't want to do copy paste work again. He want to create a template. He just want to change what and all is required. I will change it. That's what you also do. First time you will do interesting. Second time you copy paste and change the things. But he created a code base. He created a connectivities. Okay, whenever you want me to connect to HTTP, use this code. Whenever you want to connect a database, use this code. Whenever you want to throw an error, use this code. So he created all kind of packages. Those packages are called as Mule source. Why he kept name is he don't want to do the donkey work. He put Mule on top of name and put Mule source code. That is the evolving point of Mule Studio. And he's the CEO, Ross Mason. Now he's been changed. He invented, he created this MuleSoft, a Mule ESB company as well as that. So that is the source. I have a developer thought. So coming to here. So can you tell me how many connections between Twitter to employees? Fast, quickly. You cannot count, right? So this is very minimal impact of 5 to 6 systems. Assume I want to connect all your Twitter accounts to one follow. You should follow me. When I send a message, should receive everything. It's very easy, right? One to many, one to one. But it's a point to point. Again, I need to you follow me, like it's a point to point. Do you think in the background of the system it will be point to point? Will be a dedicated link between you and me? No. There's a different analytical engine will be running, which will be connecting all of us as a map. You know, tree, this big data and all, linear table. You cannot create primary key as a Shashi, then you'll put everything. No, you cannot keep all these things. That is our traditional way of doing it. Point to point. I have a table, I have a column, I will enter all these things, and this is the primary key, and these are my sub keys. No, this is not the model which you are looking at now. Now things should be very fast, very much faster. So to avoid this kind of mesh, we want streamline the connectivity. So who is going to do this streamlining is ESB, Enterprise Service Bus. The Enterprise Service Bus will come in between, and it will handle all the requests and manages what to be done, what not to be done, how to be transformed, and interacts with the endpoints. That way, it will manage the overhead. So without that, we will end up in writing the same code again and again. There might be copy paste issues. There might be redundant issues, like you might be knowing with some one person written with a basic knowledge of coding. You are copying the same thing instead of you are reinventing the wheel. It's anyways working. Why should I write again? Right? That is our tendency. This thing. So comparing to the models, like we have said 2 models, model 1 and model 2, and we know about model 1 very well. Whenever we say SOA, okay, SOA, we know it's a web service, but SOA is not a web service. SOA is a principle. Web services are different. Generally, people will say, when I say SOA, it's a web service. Web service is a way of doing it. Okay. So, but there were some issues when they want to do it. We have tightly coupled. We have to have WSDL, the WSDL files, there should be a target namespaces, there should be some endpoints, there should be some XYZs, and that should be compiled, that should be used. And there are many other cases where we fail in securities as well. They're very tightly secure, even though it's a very tightly security, but we cannot extend our things that easily if some changes come. Good that if you have done everything in one time, it's fine, but reusability, it's a cumbersome job, even though they have very good security mechanisms. So what is this rapidly content orchestrations and productive development cycles? I think it's very big jargons to you now, but I'll come back to these things at the end of our slides so that you understand what is rapid way of doing it. How much time you take a web service development in Java, guys? If I ask you to create a web service, hardly. Tell me some simple service who can have get and post something like that. 1 hour. How do you do that? Any jar, like what Gatsby, what is this? Access to something else. You have to use some tool and create which methodology, top down or bottom up? Which one you will choose? Okay. Why top down? You know, I'm talking about top down, bottom up. Do you know that these things? Yeah. If a guy wants to create a web service, he designs the schema first. He designs the input output first. He designs the fault schema first, and design everything. Then he creates a wizard. Then he generates the classes out of it. Right. So that is a planned way of doing it. So that I know what is input, what should be my output. In case of error, what should be my response code, error code, fault schema, everything. No, a guy who just written a Java code and it's a very good service. It is being used by one-time call. I want to make it as a service. It's a Java code which is already running. I want to make it as a service. So this is the way. Like, it depends upon your situation, which one you choose better. But mostly you should go other way around. Create a schema first and all. That is the good way of doing it. But that is not a rapid way. That is not a rapid way. Okay. In particular Mule environment, we create RAMLs. RAML. REST API Modeling Language. This is a tool. You need to tell that I need a get, I need a post, I need this URL, this is the parameter, this is my description, this is my response code, example response code. Like you can create your own schema JSONs, everything, and create it and just place it in Mule Studio. It will generate the flows for you, and you run it. It creates a REST-based service ready. You create it from Postman. That anyways we are going to see in next week. Next week or next week probably, or this week if time permits. So this will give you easy to work. This is developer friendly, especially it is not overhead to the developers. They can think of anything and they create REST in minutes. There are complicated things like trades and all that you can explore your own, but we will tell you the basics and all. Yeah, orchestration. What do you mean by orchestration?
See, orchestration is a kind of, in simple English, it's a group of people who, does different jobs actually.
Okay.
So, orchestrate means if something is given to it, since there's a group of.
I'll just simplify it, right?
Mm-hmm.
You apply a leave. Everyone applies a leave. What happens if your manager is not approving it? It goes to next level, right? How it is know that it goes to next level? There is an orchestration program. Your senior manager is not there, it should go to senior manager. If it is not there, if it is already optional leave, it should be auto approved. If it is some medical leave, you have this things. So this is a program, the orchestration has been ready, and there are some human people are also involved. A mail will be sent to your manager in case of you are avoiding this thing and all. There is some orchestration. You don't need to. This is a system. So anything orchestration, whenever it comes into your mind, you take this example. Orchestration means a task will not be completed in a one go. A task may need system interventions or human interventions or a time intervention. Maybe you create an account. It's a 24 hours it creates a time. Your ICICI bank account, you add some person, it takes 30 minutes not to transfer. There's an orchestration time-based intervention. After 30 minutes, you can able to transfer it. How it is? It is been time interval-based intervention. So it is orchestrated according to the time. Or somebody should approve. You'll get an OTP. It's a human intervention. System, by default, assume that you added something. After some time, it's happening. It's a time plus system. Right? System is taking care of it. It's auto approved. Right? So orchestration, when you design some coding will, like, you have a poller. You will poll the data based upon the time, or somebody inserted some data into the database. You poll the DB, get an event, or you are listening to a JMS queue. Somebody sent a message and the queue you subscribed it. That is an event. So these are event based. But what it should do when it got it? Either it should send it to a person as an email, thing into a database, save into a log file, multiple things, right? It's auditing into a log file, it is sending an email, it is sending to DB, so DB is system, email manual intervention, he will say reply or something, or log for auditing. So you're designing a software using Mule ESB tool as a rapid way of taking something and orchestrating into multiple things. Okay. When I say sending an email, I just change something here. I want in Telugu only, but data which is coming in English. Okay. Log is okay with English, database is English, but mail I want to do it in Telugu. What you have to do? You have to put a transformer, changing something. A will be coming to transform something, B will be sending it. Doesn't mean everything will be saved. You will still have original. I'm saying something, I'm not using the jargons. When we start the session, we use the jargon as message or a payload, like that. So I'm just giving you the understanding of these terms. When you first time you see rapidly connect and orchestrate, now you are able to correlate, right? Rapidly connect means rapidly develop our endpoints using different sources, and orchestrate means multiple steps to execute. Development cycles, it is easy to deploy, easy to redeploy again. So it will be faster, and we can have consumers. Like today, I'm talking about only a HTTP client. Tomorrow, I can include a JMS client. Day after tomorrow, I want to have file. Same logic. I want to engage multiple things. At the same time, I can throw it on web service. I can throw it on a JMS queue. I can throw it on a Salesforce. Blah blah blah. So endpoints. I was talking about endpoints. Can be many, because the core is with the ESB. So at the beginning, I said why we need ESB when we are able to do the coding in Java. Right? I can create a JMS connector. I can create a database connector. I can create a HTTP connector. But why we need a ESB? Every time you need a connector, then you need to follow some set of configurations. JMS configuration, database configuration, driver, class name, everything. But this is one-time configuration, and you don't need to write any code. You just place all the jar files is required and the driver class which you are looking at. Then database connection is done. When I show you the code, you will realize that. So that will avoid at least 20 to 30 lines of code will be got into 3 to 4 lines max. Same way, so he removed the dependency of the connectors, connections, configurations, and put only concentration on the business logic. Why we need ESB? To enhance our business logic rather than end up in developing the code in connections. Like if I want to insert 1,000 rupees into your database, what you are worried about? How to get a connection, how to write a connection pool, which database, which configuration, what is my driver, what is my statement. So simple insert statement, if I give it to you, you forget about insert statement, you're thinking about all this stuff. When I come into Mule ESB, one-time configurations, when you give this thing, you're only concentrating on the whether should I use parameterized query, whether I use dynamic query, should I use bulk update. See, now you're talking about multiple things about insert, right? It is there at that time also. That is second level. But we are worried about for the connect. Okay, connection successful. There is no null. Then I'll talk about insertion. To avoid this thing, Mule ESB is rise. So this is the architecture. So we are talking about APIs, security, management, analytics. This shaded one, you don't get anything in this classroom. Even this is very high level about security, management, analytics. We are talking about what is an API, integration, transformation, and connectivity. We'll cover all these things. Except this, nothing. So you're seeing, right? We have service, we have legacy collections, DB, then some other DB, cloud-based. Okay, software as service. You know, right? SaaS, PaaS, iPaaS, and all. So we will see how to connect them in our sessions. We use first day, we use Mule Studio, how to see and all. Tomorrow we will talk about flows, messages, controllers, filters, all the stuff as per your thing. And if time permits, we'll create small service as well, Raven service. And next day, I think web services. We'll talk about more web services. I think these first 3 days, I want all these people who attended here to be continued till end. I want to it, but these 3 days, please don't plan anything. Be here because this is very crucial to continue the next levels. Okay. Until unless it's very much emergency. Okay, we were talking about 2 ID models, right? So, what is the way? Like now, who is the people? So you treat yourself as a developer, architect, where the people are involved. So mode 1, it's an old way. Everything will be done here only. Nothing there in integration. I was telling, right? There's no integration that time. Everything will be done directly connected, right? Java code to connect database, Java code to connect to something else. Everything is Java, right? Or any other. There's no integration layer. It's doing everything here. But it is not loosely coupled because there are no APIs on top of it. You, for example, who are learned Java, right? You would have seen this README files, and there's API console, like now where you have multiple methods and all these things, right? Java API. Everybody say API means Java API means that. Java is one API. Java is one API. There are many other APIs which we have to create our own. Means we are creating our own Java API. We are creating our own API. With Java you can do anything else. That is one API. If with Mule you can create any number of APIs, then how many Javas you can create? How many languages you can create? That is the strength of this Mule. Even though it is built on Java, it is giving you an opportunity to create your own language also. Right? So I will tell you, don't get involved into the system. If you have any doubts, we have a Q&A. We can run back the slides. We can discuss. Just keep a question on slide number and on. We can talk about that. Okay. So any point platform. So what do you mean by on-premise and cloud? How many of you are aware of it except what is on-premise and cloud? Fast. If you don't know, tell me fast. No? Okay. If I want to install a software into your system, how should I do that? This you know, right? How do you do that? Either use USB, either use DVD or something else. Means I want your physical device to be there with me. Right? But I said all of you connect to this particular IP URL, use this Mule ESB software. You connect to the cloud. You will have user ID password. That is cloud. one place I install the software, I open the number of connections like 100. You are within 100, you are able to get each one connection. Everybody feels like it's my ESB, my code. You keep on working on it. You store it, you save it, you go out. You logged out. But it's only one ESB in cloud. When I say on-premise, I need to install each and individual system, right? So there might be a reason why we are talking about this thing. It provides both on-premise as well as cloud, because development may happen on-premise, your systems, but deployment may happen in cloud, so that it is accessible to on-site, offshore, across the world. If I have a license, if I have a limited license, if my company is very small or not a TechM, then I don't want to buy individual license. I want to buy a single license per person connectivity based upon the availability. Same license can be used for multiple people because number of connectivity is restricted, right? But here you got access to your system, it's up to you whether you use or not use, you are paid for it. So now future is in cloud. Why this cloud is coming to picture is to reduce the cost. I'm paying salaries. At the end of the day, I'm paying softwares and I'm paying for systems, processors, RAMs, everything. Why should I end up in paying? So if you guys learn Mule and you might be observed into Cisco, then you will get more information on the data centers, cloud, connectivity, network management, other stuff. That is vast subject because which is not related, but I'm telling you that is the future. Future is next here itself. You want to reduce the cost in physical things. Probably you may not be working in office in future. You might be working in cloud, means working from anywhere. Connect your system anywhere. You'll be a freelancer. You'll get more money rather than working in one single company. Probably in future it is on cards. It's already subcontracts and all this there. So why we are talking about cloud? So cloud, everybody you might be listening, cloud computing, cloud services, cloud software, cloud services, cloud platform. What is this cloud? So it's a simple thing. It reduces the cost of physical things and create the environment as is in on-premise in the cloud, so that it can be multiple can reuse it. That's simple jargon. I'm not talking about textbook jargon. I'm talking about my understanding. So you also understand that way. So next time when you heard about cloud and on-premise, you will be very. So this is SOA, SaaS, APIs, everything, whatever so-called jargons, any service, whether the web service or JMS service or FTP service or SFTP service, any service. Read an API, tell me what it requires, tell me what it gives. That is an API. What is an API? API tells you, boss, tell me your name. Ask the question, what is your name? This will tell you its name. Its name means like it's a point of discussion, like description. What I say? When you say, if you ask a baby, what is your name? It will say, my name is. Which school you are studying? This entire English is an API. Means you know what is the question you need to be asked. You know what should be the answer to be answered, and how many parameters you need to send in the first call. What is your name? Okay, these are 3-4 parameters. Okay, this name should be there. Until unless you provide name, you cannot get name back. If you say in place of what is your name, I put age, then I'll get age. So there's the same